Welcome to episode 4, Operators, Collections, and Getting Help. Last episode, we covered variables and types. Today, we fill in the rest of the foundation. Operators, a preview of Python's collection types, how to get help, and how to read an error message. By the end of this episode, you'll have everything you need to start writing real Python without getting completely derailed every time something. The first thing I want to talk about is augmented assignment. These are small assignment shortcuts that are worth knowing before we go further. So we already know this assignment. I'll assign the value 4 to the variable name x. Okay. If I want to add 2 to x, I can do it this way. X is, oh, okay. There's a shortcut operator, which is the plus equals. And it does the same thing, and it will add 2 to it, or 1 or 3 or 3.1 or whatever value I tell it. So it's, I don't know, maybe slightly easier to type that out. At any rate, it just means that you add 2 to the current value of x. You often will see plus equals 1 in loops, indexing the loop, the number of times you for a loop. That happens a lot, and a lot of times you'll see x plus equals 1 at the bottom of it. So we can see that it added. You can use either one of these. It doesn't. I want you to recognize it when you do see it. You can also subtract. So x minus equals 1 is the same as x equals x plus 1. And we can multiply thing. Take 3 to give us 24. And you can also divide. All right. So there's some shortcuts. If you're coming from C or Java, you might reach for X++. That is not a thing in Python. That'll give you an error. Instead, you use X plus equals 1. The math module. Python comes with a built-in library of mathematical functions, and that's called the math module. So you can unlock it with an import statement. So import math. It's offloaded from the main Python language to keep the language reasonably small. There are lots of very useful modules that come with Python, but you still have to import. So import math, pi. So this constant is built in. In a previous episode, I just said pi was equal to 3.159. I could have used a math module, but didn't want to create on modules. Also, e, the constant e is in there. Square roots. 15. Square root 2. Factorials. So the factorial of 5 times 4 times 3 times 2 is 120. Math log math e. I get 1. So this shows me that this is really a natural log. It's log base e. If I do want a log base 10, math log 100 is 10, and that gives me 2. Then to the second power is base 10. And if you wanted another base for some reason, use that instead of that 10. Math.seal for ceiling. So that will round the number up. Math.for rounds it down. We'll cover imports properly in a later episode. For now, import math gives you access to constants and functions you'd otherwise have to implement yourself or get from somewhere else. In other words, it's built in. So Python is often called a batteries included language. A lot of this, you still have to implement. Yeah, again, notice that math.square root always returns a float, which makes sense. Up here in 45, we did the square root of 2, which really is a float. Math of square root 16, that happens to be an integer, but in general, square roots certainly don't be integer. As I said, math log defaults to the natural log base E. And if you want a different base 10, for instance, pass the base after the number you. Okay, getting help. So there are ways to get documentation without leaving Jupyter. So you don't have to Google. We'll end up Googling a lot anyway, or asking ChatGPT or Claude or something like that. One way to do this is, let's say, help, and then whatever it is you want help on, whatever word you want help on inside of the parentheses. And it tells you help on built-in function, round, and module built-in. So that one built into Python. So round the number and then the number of digits. Yeah, a return value is an integer if the number of digits is omitted. Otherwise, it has the same type of number. So let's try round 16. Okay, try round 15.4, 67, round it up to only round it down. Okay, another way is to put a question mark. Math, let's get help on math square root. So the signature math square root, repeated x, return the square root of x, and it is a, see what it tells us. Tells us with round. Yeah. So it's formatted slightly different, but basically the same. You can also put the question mark afterwards. Doesn't matter. So if you're searching for a specific function, you want information about it, you can get help in this way. Okay, let's look at a preview of collection types. So Python has 4 built-in collection types worth knowing about. We'll cover each of these properly in later episodes, but let's see a few examples. So first of all, we have a list. Oops. Do that as a markdown. You can go up to the box like I showed last time. The shortcut key is to press, you can't see my fingers, but it's escape and then M. That also works. So a list, as we saw before, this is in brackets, you put whatever information you want, 8, 9, 2, 500, 4 for scores. If I want to add something to the end of this, use the append. And we can see it's here at the end. If I want to know what is the first score, then I use scores sub 0, not sub 1. Python being, Python, like many computer languages, starts indexing at 0. So this is index 0 gives you 88, index 1 gives you 92, index 2 gives you 75, and so forth. So it starts 0, index 1, 0, 1, 2, 3, 4. So scores sub 0, the value at index 0 of the list scores is 88. I can see what the length of this is. It tells me lists are the workhorse collection type. They're ordered. The order does matter. They're changeable or mutable, meaning that I can change something. So I could say scores sub, say 2 equals 0. The student didn't show up. Now let's see what scores are. And I've changed it. So you can change a list. They're made that you can change them. They're ubiquitous. You see them. Similar to lists as tuples. Tuples are also ordered. They behave similar to lists, but they cannot be changed. So you do that if you have geographical coordinates, for instance, or RGB values, or fixed configurations, or social security numbers, or something you do not want that tuple to be changed, that collection to be changed. Then you would use a tuple, and if you try to change it, you get an error. So let's say we have some geographical coordinates: 44, 8, minus 97, latitude, longitude. And if I want to pull out the latitude, I can pull out the index starts at 0, not 1. So that gives me 44. Let's say I try to change this. So I will append 99 on the back of it, and I get so this is actually on purpose. You use tuples when you don't want it to be able to changed after you assigned it. So if you do try to change it, in this case by appending something at the end of it, you get an error. So sometimes errors are a good thing. Okay. Now let's look at dictionaries. Dictionaries are key value pairs. By that, person pulls. Let's say I have name, mark, city in there, spell, my age, and that's a dictionary. So you can think of it as a tiny little database. In this that has in this case one person, and then I can make a list of these to have different people. It's a dictionary, very common. But for now, let's just think about this. And then if I want to know what that city is, index it in the brackets, a person name, person occupation. I get an error because there is no occupation dictionary. I could say person occupation this way equals. So let's make an assignment to star. Okay. And now if I look at person, it has added that occupation to it. So you're not stuck with whatever your initial dictionary fields were. You can add things to it. Okay. So you look things up by name of the field, name or city, occupation, whatever. You look it up that way, put it in brackets behind the name of the dictionary, and then that will. A set is a collection of unique elements. They are unordered. Put in 1, 2, 3, 2, 1. 1. Okay. And it's just 1, 2, 3. So list would have kept all of these in order. For a set, an object is either in the set or it's not. So 1 is in the set, 2 is in the set, 3 is in the set, and that's all there is to it. The fact that I put it in there twice doesn't matter at all as far as sets are concerned. It's either in there or it isn't. So sets 1, 2. Okay, let's make another set called primes. It will be 2, 3, 5, 7. Odds 3, 5, 7. Then I can say primes and odds. So these are numbers that are prime and also odd. So that's the intersection of primes and odds. So the elements that appear in both sets. And if I say primes or odds, that's the union. This will give me anything that's prime and odd. So 2 is prime, it's not odd, but it's in this. So it's all of the elements of primes, all of the elements of odds, throw all those together into this set. And error messages, as we just saw, error messages can actually be a good thing because they tell you that there is some issue with your code that needs to be addressed. The worst kind of errors are the ones that go by invisibly and they just give you the wrong answer and you don't know. So we saw exponentiation to the 10th power with the double star. 2 caret 10 gives you a bit shift, gives you 8, which is completely not the answer that you were, but it's not an error. It doesn't give you an error message. So those are more dangerous. So you actually like. So Python's error messages, they're actually pretty good once you know how to read them. Let's look at some of the most common ones. Let's say I try to pull up my var. I haven't defined this anywhere. So it's not in the namespace. It's not in that lookup table of variables and values because they never defined it. And that's what it tells me. It's a name error. So use the name that is not bound to a value. Name error, name my var is not defined. You can get a type error. So if you try mix types in a way that doesn't make sense, so a string plus a number, That's a type error. You can only concatenate string, not integer to string. More specifically, what that's saying is that you can do strings, but it's called concatenation. And what it does is just paste them together. So you can add two strings, that's okay. You can obviously add two numbers, that's okay. But a string plus a number, what's that supposed to be? There's also a value error, which means it is the right type but an invalid. Oh, last time we saw we wanted to make an integer out of the string that contains 1.1. And we get a value. So the type is right, it's a string, but the value can't be. There's also a zero division error. 3 divided by 0. It's a division by 0. Why is that an error? So if I have 6 divided by 2, that means that 3 times 2 gives me 6. So 3 divided by 0, that would give me some number, which when multiplied by 0 would give me 3. What would that number be? Is it 3? 3 times 0 is 0. That's not 3. 3 times, let's try pi. Pi times 0 is 0. That's not 3. Negative 48 times 0 is 0, is not 3. So anything times 0 is not going to give you 0, which is not any non-zero number. So 3 divided by 0, 10 divided by 0, anything divided by 0 that's undefined. No number that can make that true. 0 divided by 0, you might ask, also gives you 0 division error. In this case, the mathematical reasoning is slightly different. This would say what number times 0 gives you 0. Let's say it's 3. 3 times 0 gives you 0. Okay, that's pretty good. What about 5? 5 times 0 is 0. Pi times 0 is 0. Any number times 0 is 0. So if I say what is the unique number, like 6 divided by 2, it's one number, it's not multiple. So what unique number times 0 would give me 0? Well, there's no unique number, anything works. So it's the question's kind of nonsense for a different reason. 0 divided. There's also a syntax error, which is when Python cannot parse what you wrote. So if I say x equals 3 with 3 equals, that's nonsense, that's a typo. What I meant was x equals 3. If I say x equals, and my finger slips or my cat jumps on my board, then that's a syntax error because it tries to say is x equal to whatever 0 minus 9890 is, but then this j, this is syntax error. It's usually a typo. So I've already demonstrated this, and I'm sure I will again. That's episode 4. You now have the full foundation for Python: variables, types, operators, collections, and error messages. For the next episode, we'll use strings, text in Python, how to work with it, so-called F strings, stands for formatted strings, which cleans up your print statements considerably. I'll leave the notebook link in the description to the GitHub. Yeah, if you like the content, please like and subscribe. Thank you. See you in the next one.